Okay, okay. Thank you, sir. Thank you, sir. Hello, everyone. Sorry again. I think I'm visible to you all now. Yes. No. There is no problem with your phone. There is a problem with our studio, but it's okay now. Sorted. Okay. Without a delay, let's start. The chapters that we'll be doing today are structure of atom, classification, structure of atom, periodicity, and chemical bonding and molecular structure. Good morning, everyone. We'll do the greetings on the way, but as we started the class a little late. Okay, let's jump start first. Okay. Okay. All your doubts I'll take. Okay, in between I'll take your doubts. Okay, just let's start with chemical bonding first. Good morning, Vijay. Good morning, everyone. Okay, Nagraj, Tashmiya. Yes. Okay. So, 1 second. Okay, you guys have to answer. Okay. Yes. Good morning. Yes, I am a little late for class. Okay, now let's start because of some issue. Technical issue, you can say. Yes, so let's start with chemical bonding and molecular structure. Let's start with chemical bonding and molecular structure. This class is serious. You're not focusing on this or either, right? So take. Okay. Now tell me, we are given these Lewis structure for N2. These are the Lewis structure for N2. You need to tell which is the correct Lewis structure, correct electron dot structure for N2, correct electron dot structure for N2. D. Yes, D is the correct answer, right? You know how to make Lewis dot structures. Yes, a little late class, I know that. One second. Okay, there might be a little delay, Naveen, but they'll post today only. Okay, and I'll ask ma'am. Okay, I'll ask the backend team. They'll upload it as soon as they can. Okay. Yes, correct answer is D. Why? Because obviously in N2O, what are the number of electrons involved? So we have 14 from nitrogen and 8 from oxygen. That makes around 22 electrons. So firstly we'll start making like this, right? Firstly we'll start making a simple skeletal structure. Now 4 electrons are gone. If 4 is gone, then how many left? 18 electrons are left, right? Now with these 18 electrons I need to fill in such a way that each atom completes its octet. Okay, each atom completes its octet. So I'll start with oxygen. 6, 7, 8. Oxygen's octet is complete. Nitrogen has one lone pair, it forms up to 3 bond. Nitrogen has one lone pair and it forms up to 3 bond. This nitrogen can only form 3 bonds, right? After that it will have a positive charge because it donated its lone pair of electrons also. So this is the correct structure. You can count also, electrons will be 22 electrons. Naveen, if I didn't teach you properly, if I didn't solve the PYQs with you, if I didn't take your doubt sessions, then I am responsible. But if it's something that we have already provided to them and the backend team has some technical issues or they are not able to post it, that's not my issue, na? You can't just blame the teacher. I'm not the engineer working here. I just know how to teach. I just know how to make PDFs and PPTs, right? But I don't know how to, what coding to do, how to post it and all. These are handled by different people, okay, and those people have some other things going on, or maybe they have some other issues. Okay, so you can't just take your anger out on someone which you are able to just see here. I'm not the person responsible for it, trust me. Okay, I'll ask, but for your sake I'll ask. Okay, in between I'll go and I'll ask why haven't they posted yet. Okay, yes, obviously they will be uploaded by today. There might be some delay. I don't know what. I just came to office. You guys are just bombarding me with all these questions. See, I'm not responsible for the back-end management, but I am trying to take, I am worried about you because you guys are preparing really well and you guys need everything on time, which will be delivered today only, and I'll go and talk to them in between. Okay, so just be patient. Can you a little bit patience, right? Okay. let's start. This is the answer. Correct answer is option number D. And I see all of you answered option D. Okay. Next question. The formal charge on central oxygen atom in ozone. So I believe ozone has a structure like this, right? 1, 2, 3, 4, 5, 6, 7, 8. Now this has negative almost. And this oxygen will have 1, 2, 3, 4. Clear? Now see. What is the formal charge on this oxygen? How do you calculate the formal charge? So formal charge on any atom is equals to the valence electron minus the lone pair of electrons, number of valence electrons minus the lone pair of electrons minus half the bonding electrons. Minus half the bonding electrons. Okay. Okay, minus half the bonding electrons. Yes. Answer. How many valence electrons this oxygen have? 6. Lone pair of electrons 2 minus half bonding electrons. How many bonding? 1, 2, 3, 4, 5, 6. So half of 6, that is 4 minus 3, which is 1. As in plus 1, right? 4 minus 3 means the charge is plus 1. So what is the correct answer? Option C. Akshat answered C. Yes. Shravan B. No, not B. Vijay C. Yes. C. Shinchana. Yes. Done. Okay. Okay, done. Yes, so all of you agree, right? That is a formula to calculate the formal charge. Number of valence electrons minus the number of lone pair of electrons minus half the bonding electrons. That gives us the formal charge on one particular atom. Okay, clear? Now, next question. The electronic configuration of X and Y is given. You need to tell the correct molecular formula and type of bond that is formed between X and Y. Now see, X has how many electrons? 5 valence electrons. Y has how many valence electrons? 7 valence electrons. So X and Y, what do you see here? What do you see here? It looks like from the nitrogen family and it looks like from the halogen family. It looks like from the halogen family, right? I'll write fluorine here. It has 5 valence electrons. It looks like a nitrogen family, and this has 7 valence electrons. It looks like what? Halogen family, right? Now both of these I know for sure that they make covalent bonds. They make covalent bonds. How do they make covalent bonds? So how many electrons are required by nitrogen, by this X? We are talking about X. So X needs 3 electrons, right? X needs 3 electrons. How many electrons are required by Y? Y requires only 1 electron. So Y will form 1 bond, and X needs how many bonds? 3 bonds. X needs how many bonds? 3 bonds. Okay. Okay, yes, so correct answer is 2, 2, 2, 2, 2. Yes, that is correct, because X needs how many? 3. Y needs only 1. Understand? Y needs only 1 bond, 1 electron actually. This is Y's electron and this is X's electron. So Y needs only 1 electron to complete its octet. 8 electron, right? Octet is complete. X needs how many electrons? 3 electrons, right? So 1, 2 and 3. These 3 electrons are provided by 1 Y each. Okay, provided by 1 Y each. So what is the molecular formula? XY3, right? XY3. Is it clear? Yes, so everyone is answering. And what is the kind of bond? This is a covalent bond. The kind of bond that is formed is a covalent bond, right? Bond formed by sharing of electrons. Okay, yes. Clear. So Pradyun, Darshan, Venkatesh, Akshat, Nalin, Vijay, Vishwanath, Shravan, Joe, Akshat. Again, yes, everyone answered correctly, all of you. Okay, let's move on to the next question. Yes. A pair of isoelectronic species having bond order of 3. Now see, we in exam hour, in KCET exam, in your JEE exam, okay, any exam you're preparing, you don't have the time to calculate the bond order, you draw that diagram or even write the electronic configuration and then calculate it. That's not possible for you. So what you do, I'll give you a little trick. Maybe you already have that trick. So we take nitrogen. We take nitrogen. How many electrons nitrogen have as the standard? Nitrogen have 14 electrons, right? So when number of electrons is 14, the bond order is 3. When number of electrons is 14, the bond order is 3. Simple. Now if you go, this is above 14, that means you go 13, 12, 11, and if you go below 14, which is 15 electrons, 16 electrons, 17 electrons, either way you go. So let's say I'm going up, I'm decreasing the number of electrons, then your bond order would also decrease by 0.5 minus 0.5. Clear? Similarly, if you increase the number of electrons, so the standard is nitrogen. Nitrogen have 14 electrons, the bond order is 3. But if you increase or decrease the electrons, either cases, if you increase or decrease the electrons, in both the cases, the bond order decreases by 0.5. In both cases, bond order decreases by 0.5. So see here, if we go from 14 to 15 electrons, the bond order will be 2.5. Then again, 1 electron is increased, bond order will be 2.0. 17 electrons, bond order is 1.5. Similarly, if you go above 12 electrons, the bond order will be again 2, and 11 electrons, again 0.5, 1.5. So some examples we have N2, right? N2. Then we have NO. O2 has 16 electrons. O2 negative has 17 electrons. Okay. Then we have from N2 we go up, N2 positive, right? N2 positive will have 13 electrons. Similarly, C2 will have 12 electrons, right? And if we make somehow C2 positive, that will have 11 electrons. Clear? So any species, I'm not talking about these species only, these are the number of electrons that you should consider for, okay? Okay, don't worry, we'll draw some Lewis structures. We have some examples, I think. Yes, we have questions about a Lewis structure. So what is the isoelectronic species here? Good morning, Bhagya. A. All of you are answering A, correct. So how many number of electrons? N2 has 14. CO means 6 plus 8, which also means 14. Now see 14, NO means 7 plus 8. 7 plus 8, which is 15. So this is not isoelectronic. Again, these are also not isoelectronic. Why? No, 7 plus 8 minus 1. And this is 16 plus 2. So obviously these are also not isoelectronic. And here are these isoelectronic? 6 plus 7 plus 1. And we have 18. Again, not isoelectronic. So this is our correct answer. Why also? Because both have 14 electrons, and for 14 electrons the bond order is 3. For 14 electrons the bond order is 3. So remember this, okay? Number of electrons and the bond order. Take this as your standard, okay? Because it will be needed in further questions. That's why I'm asking you, okay? So the correct answer is option A. Done? Next question. Which of the following possess net dipole moment? There is a net dipole moment. So which of the following? Very easy, right? We know BF3. BF3 is planar. BF3 is planar, right? The net dipole moment is 0. There is no net dipole moment for BF3 because all these charges, all these dipole moments cancel out each other. Similarly, BeCl2. BeCl2 again same. The dipole moments are opposite in direction, same in magnitude, opposite in direction, they also cancel out. CO2 also, CO2 is also linear. Again dipole moment cancel out, so only one is correct, SO2. Only one that is correct is SO2. Why? Because SO2 does not have a linear shape. SO2 does not have a linear shape. SO2 have a bent shape. SO2 have a bent shape, and due to its bent shape it has some dipole moment, because they do not entirely cancel each other. There is some net dipole moment, some net dipole moment. Clear? In anthracene in anthracene we have number of pi bonds, 1 2 3 4 5 6 7 pi bonds we have. 7 pi bonds, so that means 7 times 2 14 electrons. Yes, correct. A 7 7 7 7. So what is the answer for this one? Anmol, Joe. Yes, Joe correct. Anmol, Venkatesh, Nalin. Okay, done. Manjul, why B? The answer is A. Only SO2 will have a net dipole moment. Why? Because SO2 is bent in shape, and due to its bent shape, it has some dipole moment. Okay, it has a net dipole moment. Yes, FF Gamer, Yushnath, Kani, again Anmol. Acha, that is answering for something else. Okay, so the correct answer is option A. Next question. Again, see, I told you don't have the time to calculate it all, right? So you just use the trick. Yes, Hema, B is not, because BF3 is a trigonal planar. It's a trigonal planar molecule, and all the bonds dipole moment. Let's say these two are not opposite, they have some dipole moment, right? But the opposite bond, this opposite BF bond has a dipole moment which is equal and opposite in magnitude. Equal in magnitude and opposite in direction. That's why it cancel out. This dipole moment cancel out, and thus this molecule have net dipole moment of 0. This molecule has 0 net dipole moment. Okay. In NH3 and NF3, NH3 has more dipole moment. NH3. Okay. NH3 and NF3. In NH3 and NF3, both have same shape, right? Trigonal pyramidal. This is the shape of NH3. Similarly, this is the shape of NF3. One lone pair, right? Here what happens, all these bonds, this NH bonds, nitrogen is more electronegative, so dipole moment direction will be where? Alongside nitrogen, right? Now in between nitrogen and lone pair, the bond direction, the dipole moment direction will be towards the electron. Okay, now see, all of these are going in one same direction, so that means all these dipole moments will add. And this will be their net dipole moment. If I show it by red, this will be their net dipole moment. Clear? Okay, now here listen, in case of NF3, what is happening? As fluorine is more electronegative than nitrogen, all the dipole moments are pointing in opposite direction, right, towards fluorine. And for this, again, lone pair, the dipole moment should be in upward direction. So as you can see, if I combine those three and there is opposite one, so something is getting cancelled, right? Both are in opposite direction, right? The dipole moment is getting cancelled, right? Because see, let's say if this is 5 and this is not 5 actually. Let's say this is 4, right? And these are -1, -1, -1. So -1, -1, -1. If 4 minus 3, which is 1 only, so the dipole moment, if something is there, it will be only small dipole moment, right? Only little. Why? Because of the highly electronegative fluorine atom connected to nitrogen, all the dipole moments are pointing towards the fluorine atom, right? And thus cancel out each other, okay? Oh, value I don't know. No one remembers the values actually. So in between NH3 and NF3, which is have more dipole moment, that is NH3. They don't ask you the value questions. Trust me, they won't. They only ask you which has more dipole moment, which possesses more net dipole moment. Okay. Value, okay. No. Kani also asked which has more dipole moment. Then he asked what is the dipole moment. Kani, are you a girl or a guy? I don't know. Yes, done. Clear, everyone is answering correctly. Done. Okay, next question. Again, answer this. We know 14 electrons. We are looking for 14 electrons. Which has 14 electrons? This has 14, right? 6 plus 8, 14. So this will have a dipole moment of 3. This will have a dipole moment of 3. B4, B4. That means either this option or this option. NO has how many electrons? 7 plus 8, which is 15 electrons. Again, as I told you, if we increase the number of electrons or decrease, in either of the cases, 0.5 is getting subtracted from 3. So here we are adding 1 electron, 14 to 15. So that means the dipole moment will be 2.5. 2.5. So that means correct answer is option 4. Correct answer is option 4. Clear? Yes, D. Bhagya, Amulya, Nalin, D. Vishwanath, Darshan. Okay, good. See, Kani, not just asking anything, like satisfying your knowledge is really good. But if you are preparing for an exam, just study that much which comes in your exam, which is for your benefit. Because, yeah, you can have knowledge or you can clear the exam, that's the thing. Knowledge is vast. You can have knowledge from everywhere and so much you can learn. This is just the basic one, right? You can learn so much more, right? But it's not required for your exam. Some things which are not required for your exam, you should not focus on them or you should not spend energy on them. So choose to spend your energy wisely, okay? Only on the stuff that is going to come in your exam, okay? I'm not blaming you or anything, but that's what most students go through. They thought that we don't know, we should know this, we should know that, but you should be that, you know, horse eye, something like that. That horse vision should be there, that yes, I want to clear this exam, I should study only this much which is coming in my exam, because obviously in this subject also there is this much, but you need to study only this much, okay? Notes. Which notes? Okay, next question. What notes are you asking? Good, Anmol, good. Next question. A pair of, again same question, having bond order of 1. In this case the bond order is not 3, the bond order is 1. So which has 1 bond order? How many electrons will have 1 bond order? Okay, which has a, so we know 14 means 3. 14 means 3. We want to go to 1, right? Okay, 14, right? 3. Then I'll go to 2.5, 2, 1.5 and 1. Okay? Okay. So that means they have around what? 13, 12, 11, 10. And in this case, we'll have 4 more electrons. 4 more electrons, which is up to 18 electrons. So which species have 18 electrons here? Which species have 18 electrons here? Yes, correct answer is option C, because both of them have 18 electrons, and for 18 electrons the bond order is 1. For 18 electrons the bond order is 1. Clear? You remember it, okay? Yes, C, Shankar, Chandana, Ashirwad, Joe, Bhagya, again, Shri, Darshan, FF Gamer, done. No ma'am, the option C is unique. We have 14 electrons here, 14. So for 14 the bond order is not 1, the bond order is 3, right? Similarly here also we have 6 plus 8, 14, right? Again bond order will be 3, not 1, okay? Yes, correct answer. Dhanesh, Anmol, Shankar, Suhail. Yes, okay. Let's move on to the next question. Bond angle in pH4 positive is more than that of pH3. The bond angle is more. So in pH4 positive and in pH3, what is the hybridization? So let's start from pH4 positive. So hybridization is 5 plus 4 minus 1, which is 8 by 2 and 4 sp3, right? Here hybridization is 5 plus 3, 5 plus 3. Again the hybridization is 4, right? Same, hybridization is same. Same hybridization, so their bond angle should be almost same, right? But their bond angle is also not same, okay? pH4 positive has more bond angle than pH3. Why is that? Yes, why is that? But the shape is different. This has tetrahedral and this has trigonal pyramidal. Trigonal pyramidal. What is the difference? Why? So very simple, very easy. We have pH4 positive. It has tetrahedral shape. Tetrahedral means shape like this. Clear? pH3 has shape like this, trigonal pyramidal. That means it's like ammonia. It's like ammonia. Now see here, there is a difference you can see. There is no lone pair for pH4 positive, but there is a lone pair for pH3. There is no lone pair for pH4 positive, there is a lone pair for pH3. Now what does lone pair do? Because of this lone pair, there are lone pair, bond pair, repulsion. Lone pair, bond pair, repulsion. What repulsions are here? Here only bond pair, repulsion. And according to which theory? Okay, you are telling, all of you are telling the correct answer. Which theory talks about this repulsions? Bond pair, repulsion, lone pair, bond pair, repulsion. Which theory talks about it? Which chemical bonding theory talks about this kind of? Yes. Which one? No, not Louis. Not Louis Anmol. Louis, no. Louis doesn't talk about this lone pair, bond pair, repulsion. Yes, okay, good. Still not, it's incorrect. Actually, the theory is your VSEPR theory, not VBT. VBT tells about the bonds actually, sigma bond, pi bond, about them, okay. VSEPR theory tells about the repulsion between lone pair, lone pair, lone pair, bond pair, bond pair, bond pair. So which are the strongest repulsion? Lone pair repulsion. Then we have lone pair, bond pair repulsion, and the weakest are bond pair repulsion. Now what will happen? Yes, VSEPR, correct, FF Gamer and Anmol. Now see, if there is repulsion between lone pair and bond pair, so that means what happens? This bond will go, this pH bond will go closer, like closer, right? And this bond angle will decrease. This bond angle will decrease. Here only bond pair repulsion are there, which are very weak. That means there is not much change in bond angle than the tetrahedral bond angle, which is around 109.9 degrees 28 minutes. 109 degrees and 28 minutes, or 109.5 you can also say, okay. But for this it's not 109 actually, there is some repulsion, right? So because of that it is 103 degrees and 103.5. It is 103.5. And for this it is around 93.5. For this it is around 93.5. Clear? Okay. Done. Hint I gave you. Okay. So the correct answer is option 4, because of the lone pair bond pair repulsion existing in pH3. There are no lone pair bond pair repulsion in pH4 positive. Okay. Clear? Next question. Answer it. Which of the following pair contains 2 lone pairs of electrons on the central atom? So let's start with I3 first. I3 positive. You had some doubt about Lewis structure, so we'll clear that here. I3 positive has how many electrons? 7 times 3 and minus 1. That means 20 electrons, right? So how will these 20 electrons go? I'm just drawing a basic structure first, because Lewis structure doesn't tells about the shape, it tells about the electron dot structure only. Okay, so firstly I'll draw the basic shape I3. Done. 4 are gone, so 4 means 16 electrons are there. 16 electrons are there, and you need to complete the octet of each and every one. Okay, so let's start by completing the octet from here. 1, 2, 3, 4, 5, 6, 7, 8, its octet is complete. Now how many? 1, 2, 6 are gone. That means 10 electrons are left. Out of these 10 electrons, again 6 are gone. That means 4 electrons are left. So we can form these 4 electrons will actually form the bond here. Yes, these 4 electrons here, like this, 1 2 3 4 5 6 7 8. Now all the iodines bond are complete. All the iodine bonds are complete. Okay, now see, this iodine has complete octet, this iodine has complete octet, this iodine also has complete octet. Now what are we looking for here? That there are 2 lone pair of electrons on the central atom. 2 lone pair. How many lone pairs are here? 2 lone pair of electrons, right? So I3 positive have 2 lone pairs. H2O, famous, very famous. We know H2O has 2 lone pair of electrons, right? H2O have 2 lone pair. On the oxygen we have 2 lone pair of electrons. Okay? On the oxygen we have 2 lone pair of electrons. Okay, so the correct answer is option A. Correct answer is option A. Okay. NF3, nitrogen has only 1 lone pair. NH3, again nitrogen has only 1 lone pair. And in case of SO4 2 negative, there is no lone pairs. In case of SO4 2 negative, there is no lone pair. So we are being asked which of the following, so basically we need to draw the Lewis dot structure to determine which of the following species in which of the following compounds, okay, the central atom has 2 lone pairs. Okay, so that we can only determine using what? Using Lewis structure. You will draw the electron dot structure. If the central atom have 2 lone pair of electrons, then obviously this is what question asked, right? So we started from I3 positive. It has around 20 electrons, right? From these 20 electrons we draw a skeletal structure, like simple one, I, right? 4 electrons are gone, so that means 16 electrons are left. Now we need to complete the octet of each and every atom. So we'll start from the outer atom. We put 6 electrons here. Its octet is complete. 16 minus 6 means 10 electrons are there. Now 10 electrons we fitted 6 electrons here. We provided 6 electrons to this iodine and its octet is also complete. So now it has around 4 electrons. These 4 electrons will go to the central atom, right? That means it has 2 lone pair of electrons. 2 lone pair of electrons. Similarly, H2O, we know H2O has how much? Oxygen has 2 lone pair of electrons. So that means our correct answer is 1A. Okay. Now for the rest options, NF3, nitrogen always have 1 lone pair, not 2. Similarly, NH3 also have 2 lone pairs. Sorry, NH3 also have 1 lone pair. NH3 also have 1 lone pair because nitrogen has only 1 lone pair. SO4 2 negative, in SO4 2 negative there is no lone pair, 0 lone pair. Okay, all the bonds, double bond, single bond, right? This is the shape of SO4 2 negative. How many lone pair? No lone pair, 0 lone pair. Okay, so that's why. Yeah, instead of answering, you guys are doing explaining. Okay, so do one thing, come here and teach. No, why sitting there? Yes, how to solve this question? 1 minute. You see the answer. You just I eliminate it. You know, NF3 1 lone pair, NH3 1 lone pair. Okay, in between these two I am confused. SO4 2 negative, I remember it has no lone pair. It has a structure like this. Okay, so that means my correct answer is option A. Okay, I'm not saying like you guys are like here for studying or you guys are here for explaining your concepts. You guys are here for solving questions, right? Okay, yes, the correct answer is option A. Next question, the change in hybridization of the aluminum in the following reaction. So we have AlCl3 and here it is AlCl4 negative. Do you know how to calculate hybridization? Very basic formula, half number of valence electron on that atom plus monovalent atoms minus charge of cation plus charge of anion. This will give us the steric number, and using the steric number we can figure out the hybridization. This formula works every time even if you do not know the structure. In this case I don't think you know, and AlCl3 everybody knows. Aluminum has 3 valence electrons plus number of monovalent atoms is also 3, chlorine. Charge is there, no charge, so we have 3, which means sp2. The hybridization is sp2. the hybridization is sp2. Now we talk about AlCl4 negative. For AlCl4 negative, what is the hybridization? Again 3, number of valence electrons 3 plus 4, and if the charge is negative, minus, so you'll add it, plus 1. Okay, so 7 plus 8, 4. So 4 means the hybridization, now the hybridization is sp3. Now the hybridization is sp3. Clear? So the hybridization changes from sp2 to sp3. sp2 to sp3, not C Bhagya. Again, FF gamer, okay, A, D. No change in hybridization state. There is a change in hybridization state. Yes. Kani, FF gamer, again Anmol, Chandana, Shankar. Good Bhagya. Okay. Yes. So how do you calculate hybridization? Half of number of valence electrons on that atom plus number of monovalent atoms connected to that atom minus the cation charge plus the anion charge. Okay. So in this case, 3 number of valence electrons is 3 on aluminum and 3 monovalent atoms are connected to it. So the hybridization came out to be sp2. Okay. For AlCl4 negative, half 3 plus 4 plus 1, which means 4, and your hybridization is sp3. Okay. Yes, the correct answer is option A. Papi, Shankar, Shrina. Okay. Shrinaik. Is there all formula in one book and all reaction? Formula and reaction. You can make a formula sheet actually. You can make a formula sheet, or you can find any formula sheet online also. You can just go and say that KCET formula sheet or any JE formula sheet. There will be all the formulas. You need to identify which you want, okay, and revise them, okay. You can find it. There will be reactions also. Okay, the percentage of S character on these compounds. So firstly, you calculate the hybridization. What is the percentage of S character for sp? 50%. For sp3, it is, sorry, for sp2, it is 33.33%. For sp3, it is 25%. So for NO2 positive, again I am calculating 7 minus 1, which is 3, which means the hybridization. Sorry, I again. Okay, half of 5 minus 1, which is 4 by 2, which is 2. 2 means the hybridization is sp. So for NO2 positive, the hybridization is sp. For NO3 negative, if I count it here only, 5 minus means plus, 5 plus 1, which again 6 by 2, which means 3, which is hybridization sp2. For NO4 positive, again minus 1, how much minus 1? 5 minus 1, so it will have hybridization sp. So what is the correct answer, you tell me? I have told you the hybridization and I have told you the percentage S character also. So yes, the correct answer is option B. Yes, the correct answer is option B. Chandana, Shankar, yes, B. Yuvraj, also B. Yes. Yes, they are good. They are good, Joe. So the correct answer is option B, because sp, sp2, sp, that means sp means 50% S character, sp2 means 33.3%, and sp again means 50% S character. Okay? Clear? Next question. The state of hybrid orbitals of carbon in, again, hybridization. Simple. From chemical bonding, mostly hybridization and VSEPR theory questions comes, okay? Okay, now answer this one. Hybridization of CO2. If I am correct, even without calculating it, I know the hybridization is sp2. The hybridization is sp2. For CH4, the hybridization is sp3, because all the bonds are single bonds, sp3. Okay. Now, if I know sp2 and sp3, I already know the answer, don't I? I already know the answer. sp2 and sp3. sp2 and sp3, right? And this again, it will have a hybridization of sp. The correct answer is option D. 1 second. Oh, sorry. Did I do? Six, 3. Yes, sp2, sp3. Yes, CO2 is linear. How to find sp2 and sp2, 3 or 1? So very easy. I told you the formula for hybridization. Write it down. The formula for hybridization is you calculate a thing called steric number. Okay? Steric number is half the number of valence electrons on that atom, plus the monovalent atoms attached to that atom minus the charge on cation plus the charge on anion. Okay, now after that if you get, let's say I got a steric number 2, minimum will be 2 only, okay, and then your hybridization will be sp, because 1s and 1p makes 2, right? Okay, if steric number is 3, that means sp2, 1s and 2p. If steric number is 4, then hybridization is sp3, again 3p and 1s. If steric number is 5, then hybridization is sp3d, right? 3, 1s and 1d, 3, 4 and 5. Okay, similarly up to 6 you can go sp3d2. This is for octahedral complexes. Okay, so yes, the correct answer is option D. The correct answer is option D. Okay, because CO2 has a hybridization of, the steric number for CO2 will be what? Oxygen is not a monovalent atom. Oxygen is a divalent atom. Okay, it forms double bond, not single bond. Monovalent means atoms, it forms single bond. Okay, which has a monovalency, valency of 1. One second, did I do? Let me just think once. Did I do something wrong here? Number of valence electron. Okay. Yeah, I did something wrong. One second. Yes. Sorry. So carbon dioxide. Number of valence electron of carbon, they are 4, right? So that means it is 2. The correct answer is option C, not D, sorry. Okay, done. Yes, I forgot this. I counted as 6 only because it is the atomic number. So no, we have 4 valence electrons, and 4 by 2 means 2, and steric number 2 means the hybridization is sp. Okay. Yes, correct answer is option C. Yes, Sudarshan, M Farzana, correct. Yes. Sorry. Okay, I think I need a break for some minutes. Okay, next question. Which of the following statement is incorrect? Again, incorrect statement we are looking for. So bond length and bond order, 2 things are given. So I'll tell you one relation. Bond order is inversely proportional to bond length. So if the bond order is high, the bond length will be less. Okay, if the bond order is high, that means bond is really strong. If a bond is really strong, that means the bond length is really small. Okay, the bond length is really small. No, Anmol, I already acknowledged my mistake. Okay, sorry, I thought I calculated it wrong. Okay, I thought 6, I took 6 instead of 4. Okay, can we just leave it? Okay. Yes, that also is there, but for that you should know the structure, no? Kani, you should know the structure, then how many sigma bonds are being formed by the central atom, or you know how many lone pairs are there, but this formula doesn't require that knowledge. Okay. Yes. the incorrect statement we are looking for. So what is the bond length of O2 and O2 2 positive? How many electrons? 16, and it has 16 minus 2 14 electrons. So which has higher bond order? Which has higher bond order? 14 means 3. Bond order is 3, and this means bond order is 2. Bond order is 2, right? So which has higher bond order? 3. That means the bond length will be smaller for this one, right? So this is correct statement. Similarly, bond order, again bond order of O2 positive and O2 2 negative. O2 2 negative means 18 electrons, okay, and O2 positive means again 16 minus 1, which is 15 electrons. So is the bond order of O2 2 negative? What is the bond order of O2 2 negative? 14, and we went 4 places, so that means around, yes, the bond order is, for this it is 1, yes, incorrect statement. O2 positive and O2 2 negative. Bond order we are talking about. So it has 16 minus 1, which is 15 electrons, and this has 18 electrons, okay? Okay, now which has higher? This has higher bond order. This has higher bond order. O2 positive has higher bond order. Yes. O2 positive has higher bond order. This is also incorrect. This is also incorrect. In between O2 and O2 2 negative, in between O2 and O2 2 negative, again 16 and 18. So obviously the bond order is high for O2. Yes, yes, yes. Similarly, bond order is high for O2 than O2 2 negative. Yes, the correct answer is option B, not C. Correct answer is option B. Yes, O2 positive bond order is 2.5. Correct. These statements are correct because bond order of O2 is more than the bond order of O2 2 negative, right? We have 16 electrons, we have 18 electrons, okay? 16 is close to 14. Yes, all of you agrees. B is the correct answer. Next question. Yes, arrange the following in increasing order of their bond order. So we'll start from here. 16 electrons, minus 1, 15 electrons, plus 1, 17 electrons, plus 2, 18 electrons. So in increasing order of bond order, right? So that means we'll start from 18, then 17, then 15, and then 16. Because again 14, 15, 16. 14 has 3, right? And if we go from 3, 2.5, 2, this is 2, this is 1.5, this is 1, this is, okay? Yes, there is class in the evening. Today we have lots of classes. The schedule is packed. Okay, yes. So the correct sequence of increasing order is O2 2 negative, O2 negative, then O2, and then O2 positive. Okay, correct order of bond. Sorry, increasing order of bond order. Okay, increasing order of bond order. Okay, so the correct answer is option D. Correct answer is option D. Okay. You don't even have to calculate it. Just remember, when we are going from 14, either way, 14 to 13, 12, 11, decreasing or increasing. Okay. In case, 14 to 16, that means very less decrease is there. 0.5. Okay. And then again, we are going down, down, down. That means more, the bond order will decrease further. Okay. Yes, the correct answer is option D. 15th question, the correct order of boiling point of the following compounds. Again, the boiling point here will depend on hydrogen bonding. Okay, which forms the strongest hydrogen bonding. So, for example, the maximum the number of hydrogen bonds. Maximum will be the boiling point. So here in HF, H2O, NH3, which forms the most number of hydrogen bonds, that is H2O. H2O forms up to 4 hydrogen bonds. H2O forms up to 4 hydrogen bonds, right? Not D, not D. So H2O forms up to 4 hydrogen bonds. HF forms only 2. So this forms 4 hydrogen bonds, this forms 2 hydrogen bonds, and this forms, but the hydrogen bonding is really weak. Why? Because in comparison to fluorine and oxygen, nitrogen is less electronegative. In comparison to fluorine and oxygen, nitrogen is less electronegative and it forms weaker hydrogen bonding, okay, than these two. So if the hydrogen bonding is weak, then the boiling point will be the least here. The boiling point will be the least here, okay. So the correct answer is option B. Okay, why? Because H2O forms 4 hydrogen bonding, HF forms 2 hydrogen bonding, NH3 forms hydrogen bonding but weaker hydrogen bonding, okay, very weak. Why? Because nitrogen is very less electronegative than fluorine and oxygen, so the extent of hydrogen bonding is also less. Bond length, obviously the bond length will be opposite, no, this is the increasing order of bond order, right? Bond order and bond length are inversely related, right? So this is the increasing order of bond order and this is the increasing order of bond length. Clear?
In the loop given by value I. So I value is consider the radius of this arm is the radius of the other arm. Find the maximum.
Okay, so yes, I'll repeat, don't worry. No, I don't have cold. Naveen, I just talked to someone. They said that they have changed the app. So please go check your mail. They have mailed you the link for the new app and all the details, then how to proceed from there. Okay. So they have been posted. PYQs have been posted. Okay. Not on the app that we told you. That's they have been shifted to a different app. So you can check your email, the registered email ID, and there you can find the steps. And please go and study there. Okay. It's okay. PYQs, all the PYQs have been posted there. Okay. And obviously go to your mail ID and follow the steps written there. Okay, yes. When will the one shot? Okay, can you repeat question 14? Yes, I'll repeat, Komal. So in question 14, we were asked to arrange these in the increasing order of their bond order. Okay, so we know the number of electrons. These are the number of electrons. So I told you, if you would have joined at the beginning of the class, I have told you that we have one standard here. What is that standard? That standard is nitrogen. Normally we take 14 electron as the standard. Okay. 14 electron. Nitrogen having 14 electron, we take it as the standard, and we know the bond order for this. The bond order is 3. The bond order is 3. Okay, and if we increase or decrease the number of electrons, if we increase or decrease the number of electrons by 1, okay, if we increase or decrease the number of electrons by 1, the bond order will also decrease by 0.5. The bond order will also decrease by 0.5, right? So if you go from, like, if you have 15 electrons, the bond order will be 2.5. If you have 16 electrons, bond order will be 2. If you have 50, again 14, 15, 16, 17 electrons, the bond order will be 1.5. Similarly, if you have 13 electrons, the bond order will be 2.5. If you have 12 electrons, the bond order will be 2. Clear? Similarly, if you increase or decrease, the bond order shall also decrease by 0.5. So here you see, we started from 15, 16, 17, 18. So as you can see, if we are going away 14, 15, 16, 17, the bond order is decreasing. The bond order is decreasing, right? So which will have the least bond order? 18 electrons, right? 18 electrons means the bond order is 1. The bond order is 1. Then 17 electrons means bond order is 1.5. 16 electrons means the bond order is 2, and 15 electrons means the bond order is 2.5. So this is the increasing order of bond orders. This is the increasing order of bond orders. So least will be for 18 electrons, then 17 electrons, then 16 electrons, and then 15 electrons. So the sequence is this one. The sequence is this one. Okay, I hope it is clear now. So this is the standard we used. Okay, okay. Shamil, give me your name, like your real name, so that the team will contact you. If you have logged in, they will have your, if you have purchased the course, they will have your details. If you give me your name, I'll provide that to the backend team. They will look into it. They will talk to you actually. Okay. How to take 16, 15, I forgot. This is the standard we use, 14 electrons. For 14 electrons, the bond order is 3, right? And if you increase or decrease the number of electrons, the bond order will also decrease by 0.5. That is the... Okay, Shamita S. Okay, done. Okay, I'll give your details to them. Okay, done. The correct answer is option D. Is it clear? Ma'am, you answered wrong when you're doing it first. Firstly, so many comments are going on. I don't understand what is going on here. For me, I don't know. I am explaining the questions. Which question was wrong? I answered this option only, right? 18, 17, 16, 15 electrons. This is the sequence. This is the correct answer for this one. Clear? Okay. Now again, if you still want to enroll in it, you can enroll in the course. We have still the batches ongoing, okay? And the price has been dropped now. It is like if you use the code 500 off KC30, okay? Yes, they are confusing. Kani, they're supposed to be confusing. They're supposed to test your knowledge, no? So chemical bonding is a little confusing chapter, even for me also. You need to calculate lots of electrons. You need to calculate the hybridization. You need to calculate the, bond orders, hybridization. Then you need to relate the bond order to bond length and all. So that's a lot of relation, lots of relation there. Okay, so they are confusing, but again, if you revise and all, it will get better. Okay, don't worry. Again, the batches have been starting. Again, I'm just informing you for all who are looking for a systematic way of studying. It's there, everything is there. Okay, and you just apply the code 5000 of KC30. Okay, next question, periodicity of elements. Okay, we'll finish this, then we'll take a 5 minutes break. Okay, Shamil, I know you are getting frustrated, which is normal, okay, but okay, 1 second. PU1 you are talking. I'll see if I have some. The basic one you will need to work on it yourself actually. I'll try. The basic, which, you know, the questions that has been asked, I tried answering them. Please say how to take O2 minus 18. O2 minus doesn't have 18 electrons. Where did I say O2 minus have 18 electrons? O2 2 minus 18 electrons, no? O2 2 minus. So we 8 times 2 minus means you add the charge 18 electrons, right? And O2 minus means we have 8 times 2, 18 plus 1. Minus 1 means plus 1. So again 17 electrons. What is there? Yeah. Now be ready, okay? For periodicity, I want you guys to be ready, because obviously, yes. Are you okay? Are you ready? Okay. So much has happened. I don't have the sense now. Okay, we'll start with this one. Which of the following doesn't form a triad? So when we talk about triad, we are talking about Dobbe-Reiner triad. Which triad? Dobbe-Reiner triad. What was Dobbe-Reiner triad? Again, the molecular mass, the atomic weight of the middle element will be equal to the average of the atomic weight of the outside two elements, okay? The atomic weight of the middle element will be the average of, arithmetic average of what? Of the outside two elements. That is your. I didn't say that. I didn't say that. Where did I say that? My God, you guys are fighting with me or something. I didn't say that. 18, 17, 16, 15. By chance, I maybe forgot it like this only, but this is right now. This is 16, 15. I marked D then, and after that I also marked D. You can't put it like that, okay? Okay. Which do not form the triad? All of the triad you have run. This is the one who doesn't form the triad. Do the maths yourself. You are given the mass. If you do the average of 35.5 plus 40 by 2, the average will come out to be 37.7 something. 37. It's not 39, okay? While I was explaining, I got fumbled, I think. So yeah, you pick on my mistakes. Nice. It's okay, no worries. Okay, sorry if I actually accidentally said it wrong. Can you repeat 15th question? Okay, I'll repeat the 15th question. The correct answer is option B. 15th question. Boiling point. Boiling point will be directly proportional to the extent of hydrogen bonding. Stronger the hydrogen bond or more the number of hydrogen bond, higher will be the boiling point. Higher will be the boiling point. Now in here we have HF, H2O and NH3. HF forms 2 hydrogen bonds. H2O forms 4 hydrogen bonds. Why? Because it has 2 hydrogens. These 2 hydrogens can form hydrogen bonds. Similarly, oxygen has 2 lone pairs. These 2 lone pairs, this oxygen can also form 2 hydrogen bonds, up to 2 hydrogen bonds. So this can form 4 hydrogen bonds. HF can form only 2 hydrogen bonds. 2 hydrogen bonds. Okay. NH3 forms very weak hydrogen bonding. Why? Because in NH3, what do you have? Nitrogen, which is less electronegative than fluorine and oxygen. So the extent of hydrogen bonding is really less. So in between H2O and HF, H2O has stronger hydrogen bonding. Okay. And in between all of these three, among all these three, NH3 has the least, or NH3 has the weakest hydrogen bonding. Okay, so this is our sequence for boiling point. Why? Because boiling point means we are breaking the intermolecular forces. Stronger the intermolecular forces, more tough will be they to break. More energy you need to break those bonds. Okay, so this is the order. This is the order. The correct answer is option B. Okay. Now let's move on to periodicity questions. We have done this question. Metalloid, which is the metalloid, means that have properties of both metals and non-metals, that is antimony. That is antimony. Okay. How can we say, Komal? We can say because we have seen the hydrogen bonding, because we know HF and H2O. In H2O there are 4 possibilities. It can form up to 4 hydrogen bonds. When have you tried, like if you fight one person, that be one-on-one fight, but if you have 4 person to deal with at single time, if you have 4 person to deal with at single time, obviously that is difficult. No, you will need more energy, right? Komal, you have very weak basics. You guys have really weak basics actually. These kind of questions shouldn't come after completing your PU1 and PU2. Now you're preparing for KCET. Why weak? Why do we know? We know because we know about hydrogen bonding. How does it happen? What is the extent of hydrogen bonding? How many hydrogen bonds do form? We know that all. Yes, the correct answer is option B because metalloid is antimony. Next, ionization enthalpy. First, correct order of first ionization enthalpy. That means we need the increasing order. We are talking about 4 elements: lithium, hydrogen, helium, lithium, beryllium. Then we have boron and carbon. Okay, they belong to same period and they belong to same period. Okay. But the groups are different. These are different groups. The groups are different. Okay. Do you know what happens to ionization energy when we go along the period and when we go down the group? So just to memorize a revision, ionization energy increases. It increases along the period and it decreases down the group. It decreases down the group. Ionization energy is the energy required to remove the outermost electron, to remove the outermost shell electron. That is the ionization energy. It increases along the period because nuclear charge increases along the period. It decreases down the group because down the group size increases. If size increases, nuclear pull decreases or nuclear charge decreases, right? If nuclear pull or nuclear charge decreases, in that case it will be very easy to remove the electron with little energy. Okay. Okay. Right? Okay. Now see. Here. Let's see which is the correct order. In between lithium and beryllium, beryllium is a noble gas, right? Beryllium is a noble gas. It has a stable noble gas configuration. Okay. Now see, in between lithium, beryllium, which have high ionization energy? Beryllium, right? Beryllium. Okay. After that, 1 second. No. Hydrogen, helium, lithium, beryllium, boron. Oh, they all belong to the same period. You guys seriously? 1 second. So lithium, then you have beryllium, then boron and carbon. So these all belong to the same period. All belong to the same period, and along the period we know that ionization energy increases. So this should be the order. Do we have option? Yes, we do. But that is not the correct answer. Why? Because in between beryllium and boron, since beryllium has a full, okay, it has 4, right? 1s2, 2s2. So it has a completely filled s orbital, completely filled. While in this case you have 1s2, 2s2, 2p1. Okay, the electron is, yes. The electron that we are removing is from p orbital, and it has only 1 electron. That is very easy to remove compared to s, which is filled. Filled here. Okay, so here the order will be reversed. The order will be lithium, boron, beryllium, and then carbon. And why not beryllium as the highest? Because again, carbon, in period when we are going, the nuclear pull increases. So the ionization energy also increases. Okay. You guys are not studying at all. You guys are just spamming the chats now. Okay. So I am taking whoever is answering. Okay. Yeah, literally. Okay, this is the correct answer, option A. Next question. X, Y, Z have these atomic numbers. So if I recall it correctly, 19, then if you add 18 electrons, we'll get 37. Again, if you add 18 electrons, we'll get 55, right? So that means these all belong to the same group. These all belong to the same group. Which group they belong to? Potassium, right? So that means this is what? Alkali metals. These are your alkali metals. So, and what are we being asked about? The ionization enthalpy. Now see, if we go down the group, the ionization enthalpy decreases, right? The ionization enthalpy decreases. So what should be the order? This is X, this is Y, this is Z. So X will have the highest ionization enthalpy, then Y, and then Z. Then Z. Which of the following is the correct answer? Y would have an ionization potential between those of X and Z. That is correct. X and Z, which is correct. Z would have the highest ionization potential. Incorrect, because Z will have the lowest ionization potential. Y would have the highest. No, X will have the highest. Why? Because when we go down the group, the ionization enthalpy decreases. The ionization enthalpy decreases. The correct order is this. The correct order is this. X, Y and Z. So the correct option is answer option D. Next question. The third ionization enthalpy is the highest in. So firstly, you should know alkali metals. Alkali metals has a configuration of NS1, right? Alkaline earth metals have NS2. Chalcogons are your oxygen family, are called chalcogons before halogens. Okay. So oxygen has what? Again NP2, and pnictogons have NP3. Third highest will be for which one? This has NP4. Before halogens, NP4. Okay, so this is oxygen family and this is nitrogen family. So tell me, the third ionization enthalpy will be highest for which? Third ionization enthalpy will be highest for which? So you see, if you remove 1 electron, 2 electron, 3 electron, there is no problem. Okay, because almost after removing this 1 electron, the ionization enthalpy will be really high, because we have entered the valence shell, because we have entered the noble gas configuration. Here it is noble gas configuration. Similarly, here we will have noble gas configuration. Clear? See, in alkaline earth metals, after removing the first 2 electrons, the third electrons need to be removed from this noble gas configuration. It already have a noble gas configuration, so you need to give really high energy to remove that. So the third ionization enthalpy will be the highest for alkaline earth metals. It will be highest for the alkaline earth metals. Again, 4 electrons are there. Third, after removing 3 electrons, fourth will be removed from this one only. No change, not that much change. Similarly, after removing 3 electrons, you will the third electron will be removed from here only. So again, no drastic change in your ionization enthalpy. Okay, yes, option B, correct. Yes, the correct answer is option B. Alkaline earth metal has the highest third ionization enthalpy. Next question. The first ionization enthalpy of the following elements are in the order. First one. Okay, see, carbon, nitrogen belong to same period. Silicon, phosphorus belong to same period. Same sequence, right? Like this only. Silicon is lying below carbon and phosphorus is lying below nitrogen. Now see here, along a period, what is the trend of ionization energy? Along a period, ionization energy increases. So this is the order. Clear? Down the group, ionization energy decreases. Down the group, ionization energy decreases. So that means the order should have been this: silicon, phosphorus, carbon, nitrogen. But look here, this has NP3, this has NP2. right? So it has half filled configuration. It has half filled configuration. Its ionization energy still will be higher than the carbon one. Its ionization energy will still be higher than the carbon one. Why? Because it has half filled, stable half filled configuration. Okay, so silicon, carbon, phosphorus and nitrogen. This is the correct sequence. This is the correct sequence. So how many of you answered silicon, phosphorus, carbon, nitrogen? That is option D. Yes, D. Why D? Because see, in between carbon and nitrogen, nitrogen has higher ionization enthalpy. Similarly, in between silicon, phosphorus, phosphorus will have the higher ionization enthalpy. Okay, now as we go down the group, the ionization enthalpy decreases, right? So this should have been the order. But we see in between phosphorus and carbon, phosphorus has a stable half-filled configuration. And due to this half-filled configuration, what happens? This has higher ionization enthalpy than carbon, because it requires more energy, because it has a stable half-filled configuration. Narendra, you are answering wrong. Yes, that is D. Okay, not B, that is D. Because here you can't expect, you can't do this, right? Because in between, still obviously it's a period we're dealing with, we are going down the group, it should be less, but NP3 and NP2, P3, when there is half-filled p orbital, it will always require higher energy than this P2 filled, you know, partially filled p orbital. Okay. So the correct answer is option D. The correct answer is option D. Next question. Which element? So as you can see here, there is a high difference between the ionization third and fourth ionization enthalpy. There is a really high difference between third and fourth ionization enthalpy. Okay, so that means there are 3 valence electrons. That means there are 3 valence electrons, and after that the electron is getting removed from a stable noble gas configuration. 3 valence electrons are there, and the 4th electron is getting removed from a noble gas configuration. Okay, which among the following has 3 valence electrons? Aluminum. 4th electron is removed from here. Three electrons are removed from here, and 4th electron will be removed from this stable noble gas configuration. Okay, yes. So the correct answer is option D. Now before we start structure of atom, firstly be ready with your pen and paper, okay, and I'll be back in 5 minutes. Okay, I need a break, 5-minute break. Okay, I'll be back. Good morning everyone, good morning. Okay, so let's start. The break is over. Okay, let's finish it. We have structure of an atom. So as I told you, be ready with your pen and paper, because in this you will be doing the calculations. First question: according to Heisenberg uncertainty principle, the value of delta V times delta X for an object whose mass is this much, whose mass is given. Okay, so here one thing you should be clear: according to Heisenberg uncertainty principle, what is there, that the product of, you can't determine the position and the momentum, the position and the momentum at the same time. For a very small particle, you can't determine the position and momentum at the same time. There will be some uncertainty to it. And what is that uncertainty? That is your, that should be greater than, less than or equal to h by 4 pi. H by 4 pi. That is your Heisenberg uncertainty principle, that when you are dealing with very small species, like small particles like electrons, right? So for those, you can't determine the position and the momentum simultaneously. There will be some uncertainty to it, and that uncertainty is equal to or less than equal to or greater than h by 4 pi, equal to or greater than h by 4 pi. Okay, h is again your sound is not loud. Yes, this is my last class. After that I'm leaving anyway, so yeah. Am I not audible to you all? Sound is not loud. Sound is working fine. Okay, so here we were asked delta V times delta X. So there is no direct relation, so we will derive the relation. Okay, we will derive the relation. See, delta X times, what is momentum? mv, m times delta V. V is velocity, m is mass, greater than equal to h by 4 pi. So if I take it that side, can I take it? Yes, I can take it on that side. I will get h by 4 pi m. Clear? H by 4 pi m. This is what being asked, delta V times delta X. These all the values are given. So if I put it here, h is 6.626 times 10 raised to power minus 34. Planck constant, okay, 4 times 3.14 times kilograms, 10 raised to power minus 6 kilograms. So if you calculate it, actually, okay, you calculate it. Yes, Darshan, Vishwanath, okay, you guys calculated it. Yes, the correct answer is 5.2 times 10 raised to power minus 29 meter square second inverse. That is delta V dot delta X. That is the value we are being asked. Okay, we calculated it using Heisenberg uncertainty principle. We did not know any direct relation between delta V dot delta X, so we did put the value for momentum, which is m delta V. We shifted the m on the right hand side. Okay, and that's how we calculated it. Okay, clear? Okay, C, yes, Shankar, C, Darshan, Vishwanath. Okay, next question. The number of protons, neutrons and electrons in this species, very easy, right? 16 sulfur, 32 2 negative, right? What is the number of protons? These are the number of protons. Number of neutrons. What is the number of neutrons? That is mass number minus atomic number. Mass number is 32 minus atomic number is 16. This will give us the number of neutrons, which is 16. So number of protons is 16, number of neutrons is 16, number of electrons is what? Number of protons, this is equal to number of electrons, but it has a charge of -2 also. That means 2 extra electrons are also there. It has a charge of -2. That means 2 extra electrons are there. Okay, so that is 16 plus 2, which is 18 electrons. So these are the number of protons, these are the number of neutrons, these are the number of electrons. The correct answer is 16, 16, 18, which is option B. And majority of you are answering option B. That means you understand it. Okay, next question. If a wavelength of a photon is given and you are given the Planck constant, then you need to tell the momentum. So you know a relationship, the de Broglie relationship between momentum and wavelength. What is that? It is equals to h by p. P is momentum, h is Planck constant, lambda is your wavelength. Okay, we need momentum. We need momentum of this photon. Okay, so momentum will be equals to nothing, h by lambda. What is h? 6.6 times 10 raised to power minus 34 by lambda is 2.2 times 10 raised to power minus 11. If I calculate it, it will come out to be 3 times 10 raised to power minus 23 kilogram meter second inverse. That is option C. Yes, correct. Option C, correct. Okay, so because we know according to de Broglie, the wavelength is related to momentum in this way, lambda is equals to h by p, right? And so momentum will be h by lambda. We know h, we are given the lambda, we can calculate it, simple, right? Next question, same relation you'll use here. We are given wavelength and we are given momentum also. So we are given two objects A and B, two particles are given. Particle A has a wavelength of 33.33 nanometer. Particle B has a wavelength, we don't know, we need to figure out. We need to calculate the wavelength for particle B. Okay, now see. Momentum for A is PA. Let's say the momentum for A is PA. The momentum for B is 1/3 the momentum of PA. 1/3 the momentum of PA. So that means momentum of B is 1/3 of momentum of PA. We know, what do we know? We know the relation between wavelength and momentum. We know the relation between wavelength and momentum, that means they are inversely related. Okay, so now we are dealing with two particles. I can rewrite it as like this, lambda A by lambda B will be equals to PB by PA, right? Because wavelength is inversely related to momentum. Wavelength is inversely related to momentum. Okay, so we need this value. We need the wavelength of B. We need the wavelength of B. So I'll substitute the values, 33.33 by lambda B equals to PB is what? 1 by 3 PA. 1 by 3 PA by PA, right? Now these will get cancelled. 3 will go that side. So we will have 3 times 33.33 equals to lambda B. That is 99.99, which is around 100 nanometer. 100 nanometer, right? Because this wavelength is in nanometer. Okay, now nanometer, we have to convert the nanometer into meter. So we'll multiply it 10 raised to power minus 9. Your answer will be 10 raised to power minus 7 meter. 10 raised to power minus 7. 1 times 10 raised to power minus 7 meter. So yes, option D. Yes, Akshat, correct. Option D, and Shankar also D. Yes, correct. Option D. Next question, the number of angular and radial nodes. So angular nodes and radial nodes, how do you calculate it? Very simple formula. Angular nodes is equals to L. The value of L is equals to the angular nodes. Okay, radial nodes are equals to N minus L minus 1. L is your angular momentum quantum number. Okay, azimuthal quantum number or angular momentum quantum number. N is your principal quantum number. This is your principal quantum number. Okay, minus azimuthal quantum number minus 1. So for 3p we are calculating for 3p. Let's calculate the angular nodes first. So you have read this, right? S, P, D, F. For all of these we have the value of angular momentum quantum number as 0, 1, 2, 3. For P, the value of L is 1. For P, the value of L is 1. Okay, so for 3P, the angular node or the angular node will be 1. The angular node will be 1. Okay, what about the radial node? Radial node will be 3. Why 3? Because obviously the principal quantum number is 3. 3 minus 1 minus 1, which is again 1. So the answer is 1, 1. 1, 1, option B. And I have seen all of you, almost all of you. Now all of you answered B. Okay, good. Next question. The correct set of quantum number for the unpaired electron of chlorine atom. So chlorine has what? 17, right? 1s2, 2s2, 2p6, 3s2, 3p5. right? This is the electronic configuration. We are asked the quantum number associated with this 3p5, this unpaired electron of chlorine atom. So what is the value of principal quantum number? 3. What is the value of azimuthal quantum number? For p it is 1, okay, 3 1. M will have a value of -1 to +1, -1 to +1 including 0, right? Any of these values will work, okay, -1. Okay, S will have a value of ±½ So which have 3 1 1 -2 ±1/2, 3 1 1 ±1/2, okay? Option D. Option D. Correct set of quantum number for this 3p. For 3p, the principal quantum number is 3. The azimuthal quantum number is 1 for p. M can have a value of -L to +L including 0. So that means -1, 0, +1 is possible. And for S, it is ±1/2. 3 1 1 1/2. 3 1 1 ±1/2. That is the correct answer. Okay. Next question. With regard to photoelectric effect, the correct statement. Photoelectric effect. Very simple. We have a metal plate, and on this metal plate, if we incident a wavelength, if we incident a radiation of any particular wavelength, okay, then some electrons get ejected from it. Some electrons get ejected from this metal surface. This is your photoelectric effect. Ejection of electrons on incident radiation, on incidenting a radiation of a particular wavelength on a metal surface, that is your photoelectric effect. Okay, now we have 2-3 things. We have kinetic energy and number of electrons. Kinetic energy of electrons and number of electrons. So very simple relation. Kinetic energy of electrons is directly proportional to the frequency of incident radiation. Frequency of incident radiation. And the number of electrons ejected or emitted from this surface is directly proportional to the intensity of the incident radiation, is directly proportional to the, I'll write here, number of electrons ejected is directly proportional to the intensity of incident radiation. Intensity of incident radiation. So which is the correct answer here? Option, let me just see once what you guys answering. Option C. Yes, the correct answer is option C, as the number of electrons ejected increases with the increased intensity. Okay, frequency deals with the kinetic energy, intensity deals with the number of electrons ejected. Okay, yes, so all of you are answering correct. C is the correct answer. Okay, sorry. Next question. The orbital nearest to the nucleus. So again, we know an effect called penetration effect. That means the ability to stay close to the nucleus. The strongest, what is the order of penetration effect? That is S, P, D, F. S has the strongest affinity to lie close to the nucleus. So which is S? C, 4S, right? Yes, C, 4S. Okay. Next question, the energy associated with first orbit of helium. So you should know there is an energy relation, 2 energy relations for nth orbital. N is the nth orbital, that is -2.18 times 10 raised to power -18. Yes, Z square by N square, joule. Z is your atomic number, N is the number of, N is the principal quantum number. N is your principal quantum number. This is the relation when you are calculating the energy of the nth orbital, in joules. If we are calculating in electron volt, the relation is this, -13.6 Z square by N square. Now we are talking about helium. Okay, helium positive. So yeah, helium positive. Okay, what is the atomic number of helium? 2. Yes, the atomic number of helium is 2. Yes, so we will use this relation because the answer is in joule, so we will use this relation. Okay, so En will be equal to -2.18 times 10 raised to power -18 times Z is 2 and N is 1, because obviously 1 is 2, the configuration is 1 is 2, right? 1 joule. So your answer will be -8.72 times 10 raised to power -18 joule. Option B. and all of you again answering option B. Good. Last question, I think. So we have the energy of electron in the nth Bohr orbit of hydrogen atom. For hydrogen atom, again, I told you the formula for electron volt is again minus 13.6 z square by n square. What is the atomic number of hydrogen? 1, right? The atomic number of hydrogen is 1. So that means Z is 1. Clear? Again, n they did not put any because we are talking about the nth Bohr orbit. We have not defined the orbit, which orbit we are dealing with. We are talking about nth Bohr orbit. Okay. So En will be equals to minus 13.6 by n square. Minus 13.6 by n square in electron volt. In electron volt. Option A. Good. Yes. The correct answer is option A. Okay. And I think we are done. Okay, now if you have any doubt, that is a way how to be, you should be decent in your class. If you have any doubt, you ask now. I'll answer your doubts. Okay. We have time now. Yes, correct. Okay, tell me if you have any doubt. Okay. Okay, thank you everyone. I think if you don't have any doubt, so let's end the class. How to increase my speed? Comet gas speed measure. Sometimes I just don't know which formula approach I should take. So Akshat, right? Yes. So firstly, you have two things. Okay. You have either speed or you have accuracy. Firstly, what you should focus on should be your accuracy. This should be your first priority. Right now you have time, okay? You can make errors, you can make mistakes, you can learn from those mistakes, okay? You have this thing in your hand, accuracy. Work on your accuracy first. If you are able to answer, even if you are taking longer than normal, okay? Let's say one question comes here and you are taking 2 minutes to solve one question. Obviously that is long, but still you are getting the correct answer. Even if you are solving, let's say one student, we have a student A and student B. That student A is solving 50 questions every day. This student B is solving only 20 questions every day. Out of these 50 questions, only 15 questions are correct. He is solving fastly, only 15 questions are correct. Okay, but this student who is solving 20 questions, he is able to solve 17 questions correctly. 17 questions correctly. This person is working on accuracy. So start with building accuracy first. If you are able to, solve the questions correctly, okay, if you are accurate, this will help in speed. Because if you practice on your accuracy, after some time you will see that you are able to remember the formula, you are able to correlate so fastly. Firstly, work on accuracy, and second priority should be speed. Because if you have speed and no accuracy, then obviously your paper will be done, but all the answers are wrong. But if you have accuracy, even if you have attempted 50 questions, only like 40 questions, out of those 40 questions, there are chances 35 are correct. And there is no negative marking. There is no negative marking, okay, for Comet K. So work on your accuracy and then work on your speed. You have time. Obviously, I'm not saying that every time you take your time. Obviously, after working on it for 5 days, 10 days, you start to think that I can solve this question rather quickly than I solved it before, right? So that's how you little, in your mind also you put that, oh, I have to, I know the correct idea, I have the confidence for it, now I can do it a little early. Now I can use the speed factor here, okay? Yes, see you in the evening class. Today we don't have any evening class. Do we have? No, evening class is with other teacher, I think. Yes, but obviously speed is important. But if you don't have the accuracy, it doesn't matter. Okay. Good. Okay, now I think we are done. We're good to go. Okay, thank you everyone, and if any of your doubt are remaining, 1-2 guys, I remember they only come here to complain about Comet K or KCET batches. We are here for the 15-day challenge for our YouTube champions, okay? Yes, so please study. We have done all the PU2, PU1 chapters in chemistry. I think after this we'll start with questions, any revision thing will be going on, okay? Okay, so Bhavya, the Comet K classes, you get a mail this morning. This morning a mail might have come, okay? In that mail, they have shifted the content to a different app. So they have given you all the directions on how to download the app, how to access the lecture and everything. It's there, and the PYQs and one shots are being uploaded there, so you can just go and check, okay? It's in your mail, okay? Okay, thank you everyone. Take care. Bye bye. Okay? Yes. Take care and all the best for your exams, okay? Bye.